Welcome to this explainer. If you've ever wandered down the electrical aisle at your local hardware store, you've probably felt just completely overwhelmed by the sheer volume of gadgets, wires, and specialized hardware on the shelves. Honestly, it can look like an entirely foreign language of brass, plastic, and steel. Well, today we are going to demystify all of that. We're going to break down the physical components that bring power to our buildings, turning that whole wall of confusion into a crystal clear understanding of the electrician's world.
Okay, let's dive right into this. The entire universe of electrical work essentially boils down to two distinct pillars. On one side, we have the arsenal. These are the specific, highly specialized tools required to manipulate, cut, and secure components safely. And then on the other side, we have the architecture, the actual physical materials, the wires, the switches, the breakers that are left behind inside the walls once the job is done. Simply put, you can't have the architecture without the arsenal to build it.
To make this easy to follow, we're going to take a logical tour today. Essential hand tools, power distribution and controls, cables, wires, and conduits, and lastly, essential fixings and fasteners.
All right, kicking things off with Section 1, Essential Hand Tools, or as I like to call it, the arsenal of the trade. Think about your standard flared tip screwdriver. Great for everyday tasks, right? But right alongside it in an electrician's kit, you're going to find something called a stubby posidrive. Now, why on earth does an electrician need a screwdriver that's literally only 2 inches long? Well, because electrical work often happens inside cramped socket boxes, behind heavy appliances, or tucked inside tight consumer units, where a standard handle just isn't going to fit. It's a perfect example of form following function. You need the exact right profile for the space. Now, what's really fascinating about these cutting and turning tools is how strictly defined their uses actually are. Take side cutters, for instance. An amateur might try to use these to pry a nail out or twist a really tough piece of metal. But a professional, they know side cutters are strictly for cutting cables or other soft materials to length. If you use them on hardened steel, you are absolutely going to ruin the blade. It's the same with combination pliers. They give you flat and round jaws for gripping, plus a shearing edge. Every single tool here has strict parameters to keep the tool itself, and, of course the electrician, totally safe.
And that brings us to a highly specialized tool that perfectly illustrates why professional gear matters, the crimping tool. Look, this isn't just some fancy pair of pliers. When an electrician joins two cables together using a crimp, that connection has to be absolutely flawless. If it's even a little loose, it can arc and start a fire. So the brilliant mechanic of this specific tool is its internal ratchet system. Once you start squeezing it, there is literally no going back. It will not release its grip until sufficient, safe pressure is applied. It physically forces you to make a perfect, tight connection every single time.
Next up, let's talk about striking tools. Now, you might think a hammer is just a hammer, right? But look at the contrast here. The lump, or club hammer, is an absolute heavy-duty beast. It's used right alongside a chisel to literally chop into solid brick walls just to create the square holes for socket boxes. But then, look at the cross-peen hammer. It's got this tiny, narrow head on one side specifically designed to tap in tiny panel pins while you hold them in your fingers. That way you're not smashing your thumb. It really is brute force versus absolute precision.
And sometimes you'll find a tool with a feature you'd never even expect unless you were actually in the trade. Take the flooring saw. According to our source, it features a, quote, double-sided blade to get into awkward slots. What that means is it has teeth on the top of the curve as well as the bottom. That allows an electrician to just plunge the saw directly into a floorboard without having to drill a starter hole first. It is a brilliant time saver when you are stuck needing to run wires under the floor.
Okay, moving right along to Section 2, Power Distribution and Controls. This is basically the heart of the whole installation.
Let's translate some of that heavy trade jargon, shall we? When power actually comes into your building, it enters what's called a consumer unit. And inside that unit sits the MCB, or miniature circuit breaker. These things act as the ultimate safety gateways. If too much power tries to flow through a circuit, say you've got a short circuit or an overloaded plug, the MCB physically trips and breaks the connection instantly to prevent a fire. And they sit neatly right alongside the 100-amp DIN mounting isolator, which is basically the big master switch you can throw to shut off power to the entire board. So once the power leaves the breaker, we obviously need a way for humans to interact with it. To do that, we use a surprisingly chaotic variety of switches. You've got your standard one-way switch, simple on and off, easy. But what if you want to turn a hallway light on at the bottom of the stairs and then off at the top? Well, that requires a two-way switch.
And if you want a third switch right in the middle of that exact same hallway, that's where the super complex intermediate switch comes in. We also see modular grid switches here. This is where the actual switching mechanism clips into a metal frame independently of the front plate, which allows for completely custom switch panels.
Which leads us perfectly into Section 3, cables, wires, and conduits. We've got the power, now we need the delivery method.
Often, wires need physical protection as they travel along walls or across ceilings. And this brilliantly illustrates a choice electricians have to make every day: PVC versus metal conduit systems. Now, PVC conduit is lightweight, it's easy to cut, and it's great for standard indoor routing. But contrast that with heavy-duty galvanized metal conduit, complete with its couplers and brass bushings. This metal system is exactly what you'd use in a factory, a garage, or honestly anywhere a forklift might accidentally bump into a wall. It provides hardcore, rigid physical protection.
Now, to get those solid conduit pipes around corners, you use directional boxes. And whether you're working with PVC or metal, the logic is exactly the same. A through box just lets cables pass straight on through. An angle box gives you a crisp 90-degree turn. A T-box lets you branch off a single run of power to multiple destinations, and a stop end just caps the system off entirely, usually right behind a light switch. Basically, it's plumbing fittings, but for electricity.
While your house uses those standard gray flat cables, commercial buildings require some seriously intense specialty cables. Two heavy hitters here are MICC, that's mineral insulation copper cables, and the FP200 cable. These are definitely not your average wires. FP200, for instance, features a very specific layered setup. We're talking of protective screen, dedicated conductors, and specialized insulation, all completely designed for fire protection. If a building catches fire, these are the cables that ensure the fire alarms and emergency lights actually keep working. And when cables need to run underground or outside, well, that's where we see the absolute heavyweights of electrical architecture. Take PVC/SWA/PVC. That stands for Steel Wire Armored Cable. It literally has a thick layer of galvanized steel wires wrapped right around it just to stop a shovel from accidentally slicing through it in a trench. And to properly terminate that armored cable, or that MICC cable we just mentioned, you can't just tape it up and hope for the best. You have to use highly specialized brass glands and compression rings to maintain a weatherproof, completely locked-down seal.
But here is a highly practical, fascinating question. Let's say you just built 30 feet of twisting, turning metal conduit piping. How do you actually get the floppy electrical cable inside it? You use a fish tape or a draw wire. This is a crucial tool that connects our arsenal right back to our materials. It's essentially a stiff but flexible reel of wire. You push it all the way through the empty conduit, hook your electrical cables to the far end of it, and then physically draw them back through the pipe. It's so simple, yet totally essential.
All right, we are entering the final stretch. Section 4, Essential Fixings and Fasteners. These are the final details. Look, having the absolute correct gauge of electrical wire means literally nothing if your consumer unit just falls off the wall, right? Choosing the right fastener is critical. If you're attaching a heavy component to solid brick, you'll drill a hole and pop in a nylon plug, which expands and grips that brick when a screw enters it. If you're mounting to hollow drywall, you're going to use a specialized metal plasterboard fixing, which physically threads itself deep into the soft board. And for serious, heavy-duty mounting, like hanging heavy cable trays, you rely on thick metal coach bolts. And these fasteners can get hyper-specific to the exact cable being used. Remember that fire-rated FP200 cable we talked about earlier? Well, you can't just jam that into a metal box. Our source highlights this white nylon stuffing gland, noting it's used exclusively with FP200 installations. It perfectly grips the red outer sheath of the fire cable, ensuring that the entry point into the electrical box is safe, totally secure, and maintains the integrity of the fire rating. So the crucial point here is this. Electrical work is really this beautifully structured ecosystem. It's a constant, intricate dance between the physical force of the hand tools and the precise engineering of the materials. From the very first strike of a lump hammer to chase out a wall, all the way down to the final delicate turn of a tiny M3.5mm brass screw just to secure the faceplate of a light switch, every single item we've looked at today plays a highly specific, non-negotiable role in bringing a building to life safely. It kind of makes you look at the room you're in differently, doesn't it? Just knowing what it really takes to build it. So, here's a thought. Next time you walk into a room and casually flip a light switch, I want you to ask yourself, what unseen architecture of angular conduits, heavy-duty armored cables, and specialized miniature breakers is working tirelessly, hidden right behind that plasterboard wall? Keep exploring, keep questioning,
And thanks so much for joining me for this explainer.